Alrighty, so we are in our last set of notes for Unit 6. So exciting, I know. We're going to wrap up this unit by reintroducing Pythagorean theorem. We're going to go a step further with it this time, though. So before, we just introduced the basics of it. We used it to solve for c and figure out the length of the third side of a right triangle. This time around, we're going to have to rearrange the Pythagorean theorem and find our a, b, and c from weird situations. So I'm actually going to start with this definition in the middle of our page. And it really just says this. If a triangle is a right triangle, then the sum of the squares of the legs is equal to the square of the third side, the hypotenuse. Or another way, a and b is equal to c. So we can write out our formula, a squared plus b squared equals c squared. Now you're going to remember that a and b don't really matter which one's which. The one that really matters is that our c is always across from the right angle. C is across from the right angle. This is really just a two-step process. So I'm going to write down the two steps here. For all of these questions, no matter how difficult or crazy they get, one, you're always going to find a, b, and c. Two, you're always going to solve a squared plus b squared equals c squared. That's always it. Got to find a, b, c, solve for a squared plus b squared equals c squared. You get those two things down, you're always going to get the correct answer. So let's do the basics with a. You're going to start by identifying your a, your b, and your c. I got a here, I've got b over here, and I have c on the third side. Once I do that, I set up a squared plus b squared. That's not right. I'm going to go ahead and replace that with 13 equals x squared, or c. So from there, I'm just going to go ahead and square them out. 64 plus 169 equals x squared. Okay, got that down. I'm going to add these two together. That's going to give us 233. And I don't really care what my specific number is. I just want whatever the sum of those is equal to. Because ultimately what I'm going to do is take a square root of both sides. I'm doing this to get rid of my square. The square root and the square cancel each other out, leaving me with just an x on my right. On the left, I have no idea what the root of 233 is, so I'm just going to leave it as the square root of 233. I'm going to go to the very back of my packet. And I'm going to show you two things to never, ever, ever do. Let's say I have the same numbers again. So I have 8 squared plus 16 squared equals x squared. The first thing I never want you to do is square these out. And then you add them over and say that the right side is 233. Because now you're stuck. You lost your x, that thing went away, and you just left 233 here on the right. You can't do anything with that. This is an unsolvable problem. The second thing I never want you to do, we're going to set the same question up. We're going to get further this time. We're going to have 64 plus 169 equals x squared. Going to add these together. And what I see all the time, we take the square root here, is we say that x equals 233. That is super wrong because we lost a square root. We have to make sure the square root stays with the 233 because our answer is not 233. It's some weird decimal that just happens to be equal to the square root of 233. So make sure you keep your square root even through the answer. Okay, let's flip back to the front. So looking back to the front, we introduced the basic idea of finding a, b, c, and then solving for x. For b, I'm going to go ahead and relabel a, b, and c. Then we're going to set up again. X squared plus 7 squared equals 81 squared. Sorry, 9 squared. It'll turn into 81 eventually. Now the whole trouble this time is that our c is not x. Our c is all the way on the left side. That's not that big of a deal, because I'm going to square these out. X squared plus 49 equals 81. And ultimately, we're just going to do the same thing again. We're going to go ahead and, instead of add our numbers together, we're going to subtract the 49 over to the other side and say that x squared equals 32. Once we're there, we're going to square root 32 on both sides. We end up with x equals root 32. Now here's the bad news. We can simplify this. So whenever we want to simplify a square root, we want to make a list of our perfect squares. So I'm going to make a list. 1, 4, 9, 16, 25. We could keep going, but these are the only ones that are less than 32. I want to find the largest square that goes into 32. That's going to be 16. So I can split 32 into 16 and 2. When I do that, I want to take the square root of 16, which is 4, and then the square root of 2 is just root 2. So now we know that x is going to be equal to 4 root 2. It's a bit of a process, I know. You can watch through this again, watch through it slowly, turn down the speed, whatever you want. Not a lot of your answers need to be reduced. It only happens every now and then. And whenever you do it, you're going to use a perfect square. You can only ever reduce with one of these perfect squares, because you have to be able to square root it here to take it out of the radical. So, with all of that established, this idea of solving for x on the left is the only new thing in these notes. The rest these notes do is just make it harder and harder to figure out what your A, B, or C should be. That's why I wrote out these two steps here. You always want to find A, B, and C first, and then solve the Pythagorean theorem. For example, let's look at D. In D, we have our C, we have our B, but we don't have our A. Instead, we're told that this base length here is 22. Well, this is an isosceles triangle, so half of 22, half of the base here, is going to be 11. I know that A is going to be 11, so now I have my A, B, C for my Pythagorean theorem. All I need to do now is just set it up. So I have 11 squared plus x squared equals 24 squared. And then I solve it down and go from there. That's pretty much what the rest of these notes are. You're being asked more and more difficult questions to determine the A, B, and C, and then you just have to solve the Pythagorean theorem in more and more difficult questions. So I'm gonna hand it over to you at this point. I want you to try these yourself, and then I'll show you the setups and the answers to make sure you're on the right path. I'm gonna have you do C, finish D, I'm gonna have you try F, G, and H. I'll actually ask you to skip E. E is a very challenging question, and if you want to try it, you can. But I can also show you how to do it if you'd like. That's kind of out of the scope of these notes, though. If you want me to show you how to do E, first try it yourself, and then come to me. I'll show you in person. So, what I'm going to have you do now I want you to pause and try all the questions I circled. Afterwards, I'll show you the setups and the answers to make sure you're on the right path. Okay, so go ahead and pause and give it a shot. Okay, so the setup for C is going to be 8 squared plus x squared equals 21 squared. Your x is going to be equal to root 377. Here in D, x is going to be equal to root 455. If you want to try E, your answer is going to end up being root 259. Here in F, your answer is going to be, your setup is going to be x squared plus 7 squared equals 20 squared. And your x is going to be root 351. In G, x is going to be, your setup is going to be, 5 squared plus x squared equals 16 squared. And your x is going to be equal to root 231. And in H, your setup is going to be 3.4 squared plus 5.7 squared equals c squared. And your x is going to be equal to 44.05. So because this video is getting long, I'm going to split it into 2 parts. The second part of these notes are going to cover the converse of the Pythagorean theorem and then Pythagorean triples in the back. When you're ready to go to those next set of notes, please do. Make sure your answers are right here. Pythagorean theorem is tricky, but I know you can get it. As always, let me know if you have any questions, and we'll go to video 2.